Alright, so we are going to go on to normal mapping. And I accidentally deleted the shader I had here before, so as you can see, it's a completely new one. And I will add a float for specular color, because we will use it to make our effect much better. And I guess I'll make it decently bright. Okay, so I need to explain custom vertex things now. As you can see, it's a struct that's kind of important because we want our data to be aligned like this. And it consists of a vector 4, which is the position. We could also use a vector 3, it doesn't make such big of a difference. Then UV, which is the texture coordinates. Then the normal and the tangent. I will show that in a picture in a moment, just keep this in mind. Then what is needed for a custom vertex type is a size in bytes routine. Like, oh, actually I have this wrong. This should be 4 times that. Oh, bad me, okay. That's really, really, really bad. Oh god. It's not such big of a it's not a problem because I only have so few vertices, but if it were more, this could be horrible. And then the vertex elements. Actually, I'm not sure if this is used anymore. You had to do it in XNA 3.0. I don't know if you still have to do it, but I did it anyway. And here we define the vertex elements, which are a vector 4, since our position is a vector 4. These consist of the offset, like how many bytes into the struct lies that component. So the first component we have is a position, which is a vector 4, has the usage position and the usage number 0, because it's position 0 also in our shader. Then it consists of 4 floats, so we have an offset of 16 bytes, because the float is 4 bytes. And then there's our texture coordinate and so on. This is how you make this. And then you need to have a vertex declaration, which is created from the vertex elements. Okay. So I have the tangent and the normal inside of that. And then here's my initialized routine. This hasn't changed. I didn't delete this by accident or anything. So here's our light direction, volt view, and projection. And now we will add a new technique. I know in the previous shader I already had several techniques set up. But, oh well. In the process of writing this, I will temporarily break the texture routine, so I guess I will have to fix that in, but it shouldn't be too hard. I will compile for Vertex Shader 2.0, and my Vertex Shader function is the same. For my pixel shader, I will have a different function, which will be the normal shader function. And then this is a float 4 of the normal shader function, which gets the vertex shader output as its input and returns or the value that is returned is interpreted as the returned color. You can also return a struct and have the semantic for the color be defined in there. Then I will have to change the vertex shader output. I do not absolutely have to, but I think I should. So what I will have is I will have the light direction, and I will have the view direction in here. Now you probably think, wait, that's strange, you already have all that. Yeah, I do, but what I will do is I will transform all that to the tangent space. What that means is, I will clean that in just a second. Okay, this is in German, but my explanation is in English, so it should be alright. Let's say this is the vertex I'm drawing. Then the tangent is in the same direction as this. You get the sentiment. And the normal is in this direction. Okay, so now I get light. Now I get light from, let's say, here. And I'm looking at it from light. And I'm looking at it from, let's say, here. That's alright. That works for the lighting we used before, but now we want to use normal mapping. So let me put that in the corner. So how normal mapping works is I have a flat surface that I want to be black for the purpose of this. And then I have a normal map. And the normal map tells me how the normal at the flat surface is. So at, let's say, at this point and at this point, I have different normals. The normal of the vertex still is this, but I do not care about that. What I care about is what is my vertex at that point. So maybe my vertex here is like this, and my vertex here is like this. So if I change the vertex values in the correct way, I can have a flat surface, but, oh, come on, I will have a flat surface, but it will look as if I have a sphere on top of it, or an ellipse or something. I want to get this right. Maybe I screw up the whole video with this, but I do not care. It's my video, and you can be glad that I explain stuff and so on. Blah 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 blah. What? I know I can make it not overwrite my. Oh, I don't care. Okay. So here we go. Let's say this is supposed to be my surface. Then at this point I have a normal that is like this, and at this point my normal is something like this, and so on. So I can make a spherical shape, or at least I can make my flat surface reflect like it's a spherical shape by using this. But it would be hard to get this right if it's like this, because if now I add the vectors as they are here to the normal, so to speak, then I would have my normal, and let's say this is the same point as that one. Then I would add this. But of course what I want to add is this, because it's or maybe this, because it's almost the same. In fact, I do not want to add it, but I want to use it. But if I just used it, I would have this. And that would look really, really weird. So what we do is we transform everything, or at least we transform the light and the view direction into the tangent space. So basically, we turn the world. We want the surface to be flat. Oh god. Okay. And then we have our light as above, but it is turned a bit. And the same goes for our light or our view direction. And if we have it like this, we can use the normals that we have here in our normal map. And that is what we'll do. I will link an article explaining how the matrix to transform that is derived, but I will not go into detail here. I will just write the routine wall to tangent space, and it gets the normal and the tangent. Equals I will just cast 0 to that type, and then result 0 equals yeah, I think I normalize it. Equals, oh no, I do not normalize it, but I multiply it by the world matrix, because I want stuff to be turned in the same way that the normal and tangents would be turned. So here I think, oh I forgot a second. I can figure this out in a very short time. Okay, good. So it's the tangent and the world matrix, and then this is the normal and world matrix. And if we multiply the resulting matrix with a vector, we will transform that vector into the tangent space of our vertex. So now we have output dot light year equals mole of light year, and oh I should probably get this, float 3 times 3 world to tangent space equals I know this name is really long. You can change it to something else. Well, tangent space equals get world to tangent space matrix, and we pass it the normal first. It's input dot normal and input dot tangent. Okay, so now what we do is world to tangent space, and output view direction is the how to say, I will define this. Normally you'd have to set that with your camera position, but for this example I have the camera at a fixed spot, namely the origin. So this, and so my view direction is, wait, I'm looking from there to there, so I subtract. So my view direction is the view is the world position minus the view position, because then I'm looking from the view position to the world position, which is my view direction. And I could normalize it here, but that's pointless because in the rasterizer it gets interpolated anyway. So I think it's a good idea. We will first fix our texture shader up, because now we do not have the normal anymore, but we have a new light direction, and we know that our normal has a very specific value, which is float 3, 1, 0, 1, because it's just straight up. We are in the tangent space, so that's alright. And then times input dot idea and the negative. I made a mistake in the previous video. So do I have, what the heck did I just do? Okay, good. Now let's see. It should work the same if it worked at all. I cannot, what? Okay, this should obviously be float 3s. And what else did I do wrong? Let's see. Oh, return float for 1001. Okay, good. Then, well, it's not working properly. So where's my mistake? Let's see. I have the world TangentSpaceMatrix, which looks correct. Then I have the light direction, which should also be correct. I transform this accordingly, and right, I will see if it changes at all depending on the light direction. So now I have the light rotating slowly, but it doesn't seem like it does, right? Okay, so we will see what's going on in our texture shader. Oh, I did not normalize the light direction, but that, I think that's not the issue. So what else could be wrong? That could be wrong. Oh, I see. So now you can see that the light is rotating around. Now it's dark, dark, dark. And it should get brighter any moment. Yay! Okay. Transition looks weird, but so apparently the normal is 001 and not 010, which is strange, but well, we do not really care about that too much. Then let's go into our normal shader. So what we want to do is, let me illustrate that. We want to read the normal from our file or from the normal map. Use that normal instead of the usual normal value. That's why we transformed stuff into the tangent space in the first place. So let's start with a float 4, which is our color, and that's just the normal color from our color sampler at the input texture coordinates. Then float 3 normal will be also drawn from our texture sampler, but this time from the normal sampler. Yeah, we're getting there. Dot text dot, and there should be a dot as well. Okay, so we have our normal and our other stuff. But here's an important bit. The color values you read are between 0 and 1. But we want this to be between -1 and 1. So we multiply by 2 RGB, and there we go. And we subtract 1.0 because we want this just maps the area of 0 to 1 to -1 to 1. So that's our normal. Then we will do a multiplication for our light. Intensity is as above. It's normal times the negative of the normalized input light direction. And then the don't let me lie. Light intensity, normal, normalize, okay. Then what we want to do is we will add Specula Light, which is what I hinted at in the previous video. Oh, I can show this here. So if this is our vertex and the light and the look direction, we have the normal here, and what we can do is we figure out which vector is halfway between the light direction and the view direction. So we are looking here and the light comes from here, and we want the angle between the surface of a vertex and the and the light and the eye to be pretty much the same. So how do we figure out which vector is halfway between that? We add them together and divide by 2, or we normalize it again. I guess normalizing is better. Yeah, we should normalize. Multiplying by 2 is a bad idea. Okay. So we have our light direction and our view direction. And as you all know, adding vectors is like appending them to one another. So it's like we append the light vector, and what we gain is the eye vector, and what we get is this vector right here. And now if we normalize it, we end up with, like, imagine this was an arc. This vector here would be the vector in between them. So that's pretty straightforward. So the half view is normalized input is the input light direction, but the normalized input light direction, because our vectors need to have the same length, and our normalized input view direction. Okay, this should be normalized. And on top of that, we want this to be negative, because if we are looking in, I need this needs to be wider. If we're looking in this direction and the light comes from this direction, our half view vector would face down, but we want it to face up, so we negate it. And then, okay, we have the half view vector and we have the light intensity from just the normal lighting. Then we will calculate the ambient color. Will be pretty much as before. It will be the color times light intensity plus ambient color, and float for Specula Color will be, and now this is making stuff look really fancy. This will be the dot product of the half view vector and the normal, and we want this to, let's say, the power of 2. We could, or let's add a float and call it shininess or something. Float for, or it's just a float. Shininess equals 2. And then here goes shininess. This would be pretty good already, but we need this to be color, so I already have a specular color defined, and I just multiply that. And then what I do is I return color times ambient color plus color times specular color. And I could have like a color for the light as well, and that would go in there and stuff. But for now, let's run it and hope it works, because otherwise I will have a lot of time of my life wasted. So how did I call it? Normal sampler, okay. Because I have more than one normal. Okay. Please run now. Oh. Oh, there's a typo. Okay, again, unexpected token return. Oh, I forgot the semicolon. Now, okay, it's the same as before because I forgot to run normal instead of texture technique. So now we put normal here, and it looks pretty much the same, and I do not like that too much. I'm using the normal thing, normal shader function. I'm using the normal light intensity is input light direction that is normalized negative, and let's see, I will just use this. That seems wrong. Am I really using the specular color? Should be way... I will normalize this, but I don't think it's the issue, but it might be, you never know. Like, if it looks like this, something is wrong. I'm using the normal shader function, and the normal shader function returns the specular color times the color. What if I just return the specular color? Oh. Oh. Yeah, okay. so great. Ah, there we go. Now you see there's depth added to the picture. And the light is rotating. I might have wanted to turn that off, but it kind of shows the effect better. Now you see the wall looks much more like it has actual depth to it. Okay. But right now it gets completely dark when there's no other stuff. So we want to have an ambient color to not just have the specular color. And now it looks really bright at the moment. I might want to tune the colors down a bit. Now here's the normal ambient color and it gets darker. What the specular color does is it adds highlights at the edges and stuff. But this is a bit too bright, so I will tune the colors down a bit. Say this times 0.5 and this also times 0.5. And so there you go. Normal mapping. We have our normals, we have a really dark thing because now the light is going on top of us. And it's slowly turning, or it was behind rather. Now you can see there is some kind of depth to the wall, which is nice. Alright, the next video will be on parallax mapping. Just the basic idea is you map the normals in a texture. So on a flat surface you can say, well, I want the light to reflect as if it went in that direction or in that direction and so on. So you can simulate a surface even if there's none whatsoever. Thanks for watching. Tune in next time, maybe.